The diagram shows a rectangle with length equal to x plus 4. So there's the length, x plus 4, and width equal to x minus 1. So there's the width, x minus 1. All measurements are in centimeters. Part 1. Express the area of the rectangle in terms of x. So the area of a rectangle formula is length multiplied by width. This is not in your formula book. You have to know this off by heart. So we know that x plus 4 is the length. We were told that in the question. And we know that x minus 1 is the width. We were told that in the question as well. So we want to express the area of the rectangle in terms of x. That means x has to be in it. So we're going to replace length with x plus 4. And we're going to replace width with x minus 1. So we're going to multiply x plus 4 by x minus 1. So we can break open the first set of brackets. And we're going to have x times x minus 1 plus 4 times x minus 1. X by x is x squared. X by minus 1 is minus 1x. 4 by x is 4x. And 4 by minus 1 is minus 4. And then we simplify to get a, which stands for area. Area is equal to x squared plus 3x minus 4. So we were asked to express the area of the rectangle in terms of x. So the area of the rectangle is equal to x squared plus 3x minus 4. We could have used the box or the array method instead. So x plus 4 times x minus 1. So x times x is x squared. X times 4 is 4x. X times minus 1 is minus 1x. And 4 times minus 1 is minus 4. And then we simplify. So we have the area is equal to x squared plus 3x minus 4. So same as we got over here. So you only have to do one of these methods. You pick which one you want. So this is worth 5 marks. If the question hadn't told us that the length was equal to x plus 4 and the width was equal to x minus 1, we could have labelled it the other way around. So we could have called this the width, x plus 4, and this the length, x minus 1. So labelling the length and the width in the opposite way, just to show you that we'll get the same answer. So we use the same formula. This time we're saying the length is x minus 1 and the width is x plus 4. Multiplying them out, we still get the same answer. And likewise, using the array method or the box method, we still get the same answer. So length times width and width times length are the exact same thing. Part 2. If the area is 10 centimeters squared, write an equation in x and solve it. So that means in terms of x. So in part 1, we worked out the area is equal to x squared plus 3x minus 4. So we're going to use that. So we have area equals x squared plus 3x minus 4. Now we were told in question 2 that the area is 10 centimeters squared. So we're going to replace the word area with 10. So we have 10 is equal to x squared plus 3x minus 4. So we were asked in question 2, if the area is 10 centimeters squared, write an equation in x, which we've done, and solve it. So now we need to solve for x. Now, if there was no squared there, if it was just x on its own, so technically x to the power 1, we would do letters to the left, numbers to the right. But when there's a squared, so when it's a quadratic, we do everything to the left or else everything to the right. So it's easier to bring the 10 over to the right instead of bringing all the terms over to the left. So the 10 is going to come over the right of the equal sign and it's going to become minus 10. And then minus 4 minus 10 is minus 14. So we have x squared plus 3x minus 14 is equal to 0. So now we have a quadratic trinomial that we can factorize and solve, or we can use the minus b formula. Now, if we try to factorize this, we can't factorize it. So you have to use minus b. You can always use the minus b formula with a quadratic trinomial, but you can't always factorize. So we're going to solve our quadratic equation. So we're going to fill in an invisible 1. And then label a, b, and c. We're going to write out our formula. X is equal to minus b plus minus the square root of b squared minus 4ac all over 2a. We replace all of the letters with empty brackets, and then we start subbing into the brackets. So we're going to replace both of those a's with 1, and then we're going to replace both of those b's with 3, and then we'll replace that c with minus 14. So then we'll break the plus minus down into just plus to begin with. So minus 3 plus root 3 squared minus 4 times 1 times minus 14 all over 2 times 1 into your calculator. And you get x is equal to approximately 2.53. And then just press the back button on your calculator until you get to the plus, delete the plus and put in a minus. And you get x equal to minus 5.5, approximately. Now this is not valid as lengths cannot be negative. So our only solution is x is equal to 2.53. So if you go back to the rectangle, we can see that one of the sides was x minus 1. And if we were to use x equal to minus 5.5, we would have minus 5.5 minus 1, which is minus 6.5. And that doesn't make sense. You can't have a negative length, just like you can't have a negative area, you can't have a negative volume. It doesn't make sense. So therefore, x cannot be equal to minus 5.5. It can only be equal to 2.53. So this section here is for 10 marks. And then part 3, find the length of the rectangle in centimeters corrected 2 decimal places. So in part 2, we worked out x to be approximately equal to 2.53 centimeters. So we know that the length is x plus 4. So the length of this rectangle here is x plus 4. So we're going to replace the x with 2.53. And 2.53 plus 4 is 6.53. And we stick on centimeters, and it's already to 2 decimal places. So the length of this rectangle is 6.53 centimeters, and that's for 5 marks. If we wanted to find the width, which we weren't asked to, but if we wanted to, we would sub in 2.53 in place of the x here. So we would have 2.53 minus 1, which would be 1.53 centimeters.